Okay, let's see electrochemistry. Objective. The first question, see the electrolysis process. During the electrolysis process, the activated metals are present at cathode and anode. What happens? Okay, cathode and anode. Let's see the first one. For example, activated metals, the zinc as anode, okay, and copper metal acts as a cathode. We know very well at anode what happens, my dear students. Anode oxidation takes place. Oxidation reaction takes place. So what is oxidation? Oxidation is nothing but zinc. The solid is converted into Zn2 plus. Aqueous means anode weight decreasing and loss of electrons. So the weight of anode decreases. The second one is at cathode. At cathode what happens? Reduction takes place. The reduction means copper 2 plus aqueous. It accepting 2 electrons converted into copper solid. Means the weight at cathode increases. Okay, the weight at cathode increases. So the answer is in the process electrolysis process, by using that activated metal electrodes, the weight of cathode increases and weight of anode decreases. So increases, decreases means the first option is correct. Okay, understood? First option is correct. Okay, let's see for second one. Second one, the passage of current through the solution of certain current through a solution of certain electrolyte result in the formation of hydrogen at anode. Hydrogen gas should be formed at anode in the solution they are asked. Okay, for this case, we need to remember about deposition order of anion and cations. Deposition is inversely proportional to discharge potential. Okay, now let's see that first one, deposition order. Deposition order of anions. Deposition order of anions at anode. So which will be deposit very fast? The deposition order is CO3 2 minus is more than I minus, and then Br minus, and then Cl minus, and then OH minus. Okay, nitrate ion NO3 minus, and then sulfate ion SO4 2 minus. It is very, very important. Next, the deposition order. Deposition order of cations at cathode. Deposition order of cations at a cathode. So which can be deposited very fast? Gold Au3 plus can be deposited. Then platinum 2 plus, and then silver, means noble metals can be easily deposited when compared to hydrogen H plus ions, and then mercury, then copper 2 plus, okay, then H plus ions. After that Fe3 plus, then chromium 3 plus, and then zinc Zn plus 2, and then Mn plus 2, and then aluminum 3 plus, and then a magnesium Mg2 plus, and then calcium 2 plus, and then sodium, potassium ions, and then lithium. Lithium has a very low deposition order because it has highest discharge potential, more discharge potential, and its deposition order is very less. Now let's see that the first one, aqueous HCl. Aqueous HCl means okay, HCl can be ionized to gives H plus ions plus Cl minus ions, and water will be ionized to gives OH minus ions and H plus ions, H plus plus OH minus ions. Like here the positive ions only H plus. The negative ions are Cl minus and O minus. In the question what they are asked, among the following electrolyte produce hydrogen gas at anode. Hydrogen gas at anode means here anode oxidation will take place. The Cl minus ions converted into Cl2 by loss of electron, means half Cl2 it will produce. Okay, and cathode OH minus ions undergoes reduction to produce O2 gas. Okay, let's see the second one, fused calcium hydride. Fused means there is no water, then automatically it contains one cation and one anion, Ca2 plus plus 2H minus. Okay, at anode 2H minus converted into H2 plus 2 electrons, and cathode calcium plus 2 electrons is converted into calcium metal. So the answer is second option, fused calcium hydride. What about in sulfuric acid in water? Let's see the third option, aqueous H2SO4. Aqueous H2SO4 is present means it contains H plus ions plus sulfate ion 2H plus, and water can ionize to gives H plus plus OH minus ions. Then automatically the third one, the aqueous H2SO4. Okay, at anode O2 gas will produce, and cathode hydrogen gas will produce H2. Means H plus ions can be easily deposited when compared with here only H plus ions are present, there is no competition. That's why H plus ions undergoes reduction to produce hydrogen gas at cathode. But here among the following which can able to form hydrogen gas at anode, that is fused calcium hydride. Next fourth one, let's see the fourth one, potassium sulfate K2SO4 aqueous. Potassium sulfate is nothing but 2K plus plus SO4 2 minus, and water is present, then the water will be ionized to give H plus plus OH minus ions. So the fourth one, aqueous K2SO4 at anode, the negative ions OH minus ions can be deposited very easily when compared to sulfate ions, forms O2 gas, and cathode forms H2 gas. Hydrogen gas will forms. Okay, so the answer is second option. So just I gave clear cut idea about that discharge potential and deposition potential. Okay, different two or more than two cations and anions are present which can be deposited easily. It depends on their discharge potential. If discharge potential value is increases, then deposition will be decreases. So based on that, here electrolysis means what, ma? The ionization of electrolyte in the presence of electrical current and produce two cations and anions. Cations means positive ions goes to cathode, undergoes reduction. Negative ions goes to anode, undergoes oxidation. So that is known as electrolysis process. So electrolysis is always a redox process, means both oxidation and reduction both are taking place, means the electrolysis process is redox process. Okay, students, understood? Is very very important for NEET and JEE examination as well as in CET examination also compulsory related this concept. They are asking questions related to electrolysis. Okay, let's go for third question. During the electrolysis of aqueous sodium chloride, see, is very very important, means electrolysis of NaCl, aqueous NaCl on electrolysis, the resultant solution becomes, its pH value increases or decreases, we need to find out. See, already this kind everything we are discussed in regular classes. Aqueous NaCl means NaCl will be ionized to gives Na plus Cl minus ions. Okay, and water, aqueous medium means water is also present. During that passing of electrical current, water will be ionized to produce H plus and OH minus ions. Now the discharge potential, deposition order of anions, the Cl minus can be easily deposited when compared that OH minus ions, and then H plus ions can be easily deposited when compared with Na plus ions. So at anode, that Cl minus ions converted into half Cl2 gas and releases one electron, and cathode H plus ions goes to at cathode, accepting electrons, undergoes reduction to produce hydrogen gas. Half mole of hydrogen gas is producing, and in the resultant solution, finally Na plus ions plus OH minus ions combine to produce NaOH. Okay, this is base, so its pH value increases. pH value increases because for bases pH value is more than 7. NaCl, this aqueous NaCl, pH is equal to 7 because it is neutral. So initially, before electrolysis, aqueous NaCl solution pH is 7, it is neutral. Okay. After electrolysis, the resultant solution becomes basic nature. Then automatically pH value increases, gradually increases. So the answer is second one. Okay. Let's go for next fourth question. Which of the following statements are correct? Which of the following statements are correct? Let's see the first statement. First statement is correct. The electrolysis of aqueous NaCl produce, just now only we are discussed, hydrogen gas at cathode and chlorine gas at anode. So it is correct. Now, the electrolysis of copper sulfate solution using platinum electrodes causes liberation of O2 gas at anode and deposition of copper at cathode. It is correct only. See, electrolysis of the second option, let's see. Electrolysis of aqueous copper sulfate. Okay, copper sulfate first will be ionized to produce copper 2 plus SO4 2 minus. Okay, students, then water can be ionized to give H plus OH minus ions. Okay, it's very clear. Now, deposition order. What is the deposition order, for anions? OH minus ion deposition is more when compared to SO4 2 minus. That's why this OH minus ions can be oxidized to liberate oxygen gas. The second one is H plus and copper. If you are present, then copper 2 plus can be easily deposited when compared that H plus ions. Already just in first question, second question only I gave the total orders of cations and anions they gave. So let's see, therefore at anode O2 gas will be released, at cathode copper metal will be deposited. So in that statement what they gave, the electrolysis of aqueous copper sulfate, oxygen gas is liberated at anode and copper will be deposited at cathode they gave. So that's it is also correct. Now oxygen and hydrogens are produced at anode and cathode during the electrolysis of aqueous H2S4. It is also correct. See the third one, aqueous H2SO4. Aqueous H2SO4 means it will be ionized to give 2H plus plus SO4 2 minus, and water also will be ionized to gives H plus plus OH minus ions. So at anode O2 will be released and cathode H2 gas will be released. So the third statement is also correct. Now electrolytic reactions all are redox reactions. These all are redox reactions only, because in that reactions at anode oxidation, that cathode reduction, both are present. If in a shell or in a chemical reaction both oxidation and reduction both are present, means it is called redox reactions. So the electrolysis process or electrolysis reactions all are redox reactions. So the answer is all are correct, fourth option. Okay students, let's go for next fifth question. Faraday's laws. These are very, very important for board examination as well as in objective examination also. Regarding Faraday's laws, they are asking some questions in board examination also. And in objective examination, CET and NEET compulsory, they are asking questions. Okay, students? Okay, let's go for fifth question. So Faraday's laws means two laws are there. Faraday's first law and Faraday's second law. Okay. Let's see fifth one. Fifth question. A copper voltmeter and silver voltmeter and water voltmeters are connected in a series. Connected in a series, the current is passed for some time. Same current means Q is constant. Then the ratio of the number of moles of copper, silver and hydrogen. Okay, number of moles ratio we need to find out. See, the Q is constant. Q is constant. Then according to Faraday's second law. According to Faraday's second law, the weight of deposited of copper is to the weight of deposited of silver is to the weight of deposited of hydrogen gas is equal to their equivalent weight ratios. The equivalent weight of copper plus 2 is to the equivalent weight ratio of silver Ag plus and the equivalent weight ratio of H2. Equivalent weight ratio of H2. So the weight ratios means is nothing but weight of copper. Copper gram equivalent weight is equal to gram atomic weight by N factor. N factor of copper 2 plus is 2 means 64 by 2, and silver 108 by 1, and hydrogen means H2 is converted into 2H plus, its valence is 1, so it's 2H plus means 2 by 2. 2 by 2, then is nothing but 32, it is 108 and it is 1. Okay, now number of moles moles ratio of copper is mole ratio of silver is mole ratio of hydrogen is equal to, means weight by gram molecular weight. Weight ratio is 32 1082 means 32 by 64 is 108 by 108 is weight of H2 1 by 2 is nothing but it is also 1 by 2. It is 1 is the simplest ratio is equal to 1 is to 2 is to 1. So that is the mole ratio. Okay, this mole ratio directly also we can do. This mole ratio is directly proportional to Faradays are directly proportional to Faradays. Okay, for copper 2 plus means half mole is present. Half mole means half Faraday is required. Mole ratio is directly proportional to Faradays. 1 mole for deposition of 1 mole it required 1 Faraday. 2 moles 2 Faradays. 3 moles 3 Faradays. So this is the now the correct answer is 1 is to 2 is to 1. Third option is correct. Okay, let's see for next question. This is also same, that how much quantity of electricity is required, that is depends on the number of moles of electrons required. 1 mole of electron is present means it is equal to 1 Faraday. 1 Faraday is nothing but 96,500 coulombs. Okay, let's see sixth question. Cr2O7 2 minus is converted into 2 chromium 3 plus. So what is the N factor of chromium in this case? Here chromium oxidation state is 6, 2 chromiums are present, 2 chromiums, the total charge is equal to plus 12. And here 2 3 are plus means the total charge is plus 6. So change in the oxidation number. 12 minus 6 is equal to 6. So here in this case N factor is equal to 6 means Cr2O7 2 minus accepting 6 electrons is converted into 2 chromium 3 plus. 2 chromium 3 plus means if accepting electrons means what happens, oxidation number decreases. So if it is 1 mole, it is 6 moles of electrons required. 6 moles of electrons is nothing but 1 mole electrons is nothing but 96,500 coulombs electricity is nothing but 1 Faraday. Then 6 moles of electrons is equal to 6 Faradays. So the answer is 6 Faradays. For reduction of 1 mole of Cr2O7 2 minus into 2 chromium 3 plus ions, how much electricity, how much current is required? 6 Faradays current is required. 6 Faradays current is nothing but 6 into 96,500 coulombs. Is in case of in electrons how many? 6 into 6.023 into 10 to the power of 23 electrons are required. Okay students, so it is also very important. In the same way in manganese also they will ask MnO4 minus, okay, is reduced into Mn2 plus, requires how many Faradays? It is 1 mole. Required how many Faradays of electricity is required? See what is the change in the oxidation state? 7. 7 is converted into 2 means is accepting 5 electrons. Means 5 Faradays electricity is required in this case. So MnO4 minus is converted into Mn2 plus in acidic medium. So some cases sometimes how many Faradays or how much electricity is required for the reduction of 1 mole of MnO4 minus in acidic medium, like they will give. They won't give that product. So we know already, we are discussed from first year onwards in redox reactions are in equivalent weight concept. MnO4 minus in acidic medium is converted into Mn2 plus. So for this case, n factor is equal to 5. Okay, so this kind of questions they will ask. Means in NEET and JEE examination, as it is, questions will never repeat. So keep it in your mind. So the little bit logical and based on application based questions will comes. So for solving those, we must have idea. Complete idea is very, very important. And one more thing, negative marking is also present. So keep it in your mind and practice more and more. And before that practicing, we must have to read the concepts more and more times. Reading concepts is very, 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 very important. More and more times we must have to revise. Okay, let's go for next. Seventh question. The ratio of mass of mass of hydrogen and magnesium deposited same quantity of electricity is deposited. Then weight ratios they are asking. Q is constant. So how to solve this question? If Q is constant means their weight ratios according to Faraday's second law. According to Faraday's second law, according to Faraday's second law, if the Q is constant, then the weight of deposition of hydrogen and magnesium, the weight of H2 is to weight of magnesium is in their ratio of their equivalent weight ratios. H2 is to equivalent ratio of magnesium, Mg plus 2. So it is very clear, the equivalent weight ratio of H2 is 2 by 2 is equals to 1 and magnesium is 24 by 2 is equal to 12. So the answer is 1 is to 12. Second option is correct. Let's see the eighth question. In hydrogen and oxygen fuel cells, 67.2 liters of H2 gas is formed. The number of moles of H2. Later we have to find out weight. After that we have to find out Faraday's first law. We have to use Faraday's first law. Then how much current I value we need to calculate. Number of moles of H2 is equals to 67.2 by 22.4 liters. Is nothing but how much? Is nothing but 3 moles. Okay, now the weight of H2 is equals to 3 into 2 is equal to 6 grams. So according to Faraday's first law, the weight of deposited electrodes is equals to E into I into T by 96,500. Okay, let's see, the W is equal to 6. Okay, equivalent weight of H2 is equals to 1. Equivalent weight of H2 is equal to 1. Then time is equal to T is equals to 5 minutes is nothing but 5 into 60 seconds. And okay, T value we know that E and I value we have to calculate. So the I is equal to. So 6 is equals to 1 into I into 5 into 60 by 96,500. Then I is equals to 9 into 96, sorry, 6 into 96,500 divided by 60 into 5. Okay, this 0 will cancel, 6 and 6 will cancel. This is on simplification, we'll get 1930 amperes. 1930 amperes. Okay, see here indirectly we are used Faraday's first law. So according to Faraday's first law, the weight is equal to E into I into T by 96,500. Weight of H2 they gave indirectly. How much volume of H2 is formed? 67.2 liters of H2 is formed at STP. So 67.2 liters of H2 at STP is nothing but 3 moles. The 3 moles of H2 gas weight is equal to 6 grams. Okay, for deposition of or formation of 6 grams of H2, how much current is required in during this 5 minutes? In 5 minutes time period only 6 grams of H2 is formed. Then how much current is required? 1930 amperes current is required. Okay, students, let's see ninth question. Ninth question important ma. An electric current is passed through a copper voltmeter and water voltmeter connected in a series. If the copper voltmeter, okay, see an electric current is passing, then the Q is constant. Okay, so according to Faraday's second law, the weight deposited copper by the weight deposited hydrogen is equals to equivalent weight of copper 2 plus by equivalent weight of H2. Okay, this is nothing but copper is 64 by 32 is nothing but 32 by hydrogen 2 by 2 is equal to 1, means weight of copper by weight of H2 is equals to 32 by 1. If it is in grams, it should be also in grams. Or if it is 32 mg milligrams, then it is 1 milligram. Okay, if 16 milligrams of copper is decreased. See here 16 milligrams of copper is less. Then means how many moles, number of moles of copper is nothing but 16 by, means actually 32 is present. Out of 32, 16 is missed, means 16, means half mole is decreased. Number of millimoles, 16 milligrams is less than number of millimoles of copper decreased is half mole. The same way, the number of, if it is they are in 1:32 ratio, is 32 is nothing but 32 grams is nothing but half mole. It is nothing but 0.5 moles. Is nothing but H2 is nothing but 0.5 moles. If 0.5 moles means half mole is decreased, half millimoles decreased. Millimoles is decreased, then number of millimoles of H2 is also becomes 1 by 4. 1 by 4 millimoles. See 1 by 4 millimoles of H2 volume of 1 by 4 millimoles of H2 is equals to 22,400 ml by 4 into 1000, because 1 millimole is equal to 1000 moles divided by 1000. So 1 mole occupied volume is equal to 22,400 ml. 1 by 4 millimoles is nothing but 4 into 1000 moles. Then is on simplification we will get 5.6 ml. See here, what is the main important thing is the weight of copper and weight of hydrogen deposited is half mole and half mole. Okay, so number of moles of copper is equals to half, and the number of moles of H2 is also half. Okay, if from this half again half is decreased, half decreased means it becomes 1 by 4. It is also half is decreased, then it is also becomes 1 by 4. So 1 by 4 millimoles of H2 occupied volume, because the weight they gave in milligrams, that's why it becomes millimoles. Millimoles is occupied volume is equal to 22,400 by 4 divided by 1000, then is nothing but 5.6 ml. So the answer is second option. So here Faraday's second law we are using, just according to that number of moles of H2 we are calculated. How many number of millimoles of H2 is present? 1 by 4.